Okay, so there is number 9. So give that one a try. Well, first step, basically find the zeros, you know. Find the zeros, which means you set that function equal to 0, as you know, and solve, right? So let's start with that. So go ahead and find the zeros of that function. So take my pencil's not working again. All right, well, anyway, go ahead and try that. I'll just write with my finger in a minute. So go ahead and try that. Find the zeros there. Set that thing equal to 0. I'm going to run through roll while you do that. I'm trying to get on this do roll thing I'm supposed to do. So find the zeros of that function. And I'll run through roll. So set it equal to 0 and see what you can see. So there are 3 zeros. I'll give you that hint. You should find 3 numbers that make that thing 0. Say 7. Rania? Rania. Rania.
You get it sometimes.
Sometimes, you know, I'm on it. Keep reminding me. Victoria. Alonzo is here. All right, and Katharina. And Thea is here. And Emmanuel is here. And Gerswak. Gerswak is here. And Carlo is here. And William. Chrisman, no. No. Where are you, William? I hear a voice. There you are. All right. And Eros is here. And Tanya is here. And Kelton is here. And Shane is here. And Tim is here. And Edgar is here. And Jessica Farmer. Jessica, no Jessica. And Rong Fu, Rong. And Ray Garcia, Ray. Ivan Gonzalez, Ivan. And Martin Guadalupe is here. And Seth is here. And Shadow Lee is here. And Phoebe Lopez. Phoebe Lopez is not here. They're going to ask us all these funny questions about polynomials. It's good, though. It makes us think about polynomials. So basically, they're giving us the graph. Oh, it's off the screen. It's too bad. Wasn't it just great yesterday? Wasn't it working yesterday, right? Am I getting confused between sections? Yesterday was perfect, right? Anyway. All right. I'll quit complaining about the technology. Somebody just throw something at that thing. No, I'm just kidding. All right. So the graph is off the screen, even both screens. All right. Let me bring it over. I mean, I guess I could try to move my window. I don't know. You know me with technology. I don't know if I can do this. So, okay, it's moved on my thing, but it doesn't move up there for some reason. I don't know why. Anybody know why? Why, when I move it on the iPad, is it not moving up there? Nobody knows? I don't know.
This is a picture, right? You're in a separate app, right?
Yeah.
You have to screenshot the graph in one middle, so that way it wouldn't appear on the right.
So, like, if I went back to the original, maybe. Yeah, you might be right, huh? Yeah, so I'm just going to make this. Oh, yeah, could I do? No, it doesn't. It doesn't. Yeah, I tried to, and it kept bouncing back. I don't know. I don't got time. So I tried all that. So boom, it's doing this. Boom, and oh, it passes through here, so it goes. Like that's what they're giving me. So there's the graph that's off your screen, basically. It looks like this is hitting here at -1, and this is hitting what's that? 3 and 4. It's hitting at 3. This is hitting at 4. There, and this is hitting up at 1, 2, 3. Looks like. All right, and so here's their question: determine whether the graph could be the graph of a polynomial function. If it could be, list the real zeros, state the least degree the polynomial can. Okay, the graph shows polynomial function. The real zeros are. So what are the real zeros? What are they? Yeah, -1, 3, and 4. The places it hit 0, huh? Those are real zeros. Okay. What's the lowest degree the thing could be? It has how many turning points? Here is a TP, a turning point, and here is a TP. 2 turning points. It can be x to the 3rd or higher. Right? Does that make sense? It could be x to the 3rd, x to the 4th, x to the 5th. How do we know? Well, because if it has x to the 3rd, it has at most 2 turning points. was x to the fourth, it would have at most 3, right? So it could not be x squared, in other words. Because if it was x squared, it would only have at most 1 turning point, and it has 2. So it's not x squared. So it's x to the third or higher. You with me? Does that make sense on that? So it's x to the third or higher. We don't know what, right? Because remember, again, that says at most, right? A third degree thing doesn't always have 2 turning points. You know that. Think about the very basic x to the third. It's the snake. That has no turning points. It never goes from up to down, right? Just the plain x to the third. But other versions, like maybe x to the third minus 2x squared plus 7x, you know, whatever does.
Are those still considered turning points?
No, turning point means where you're going up and you go down. Where you're going higher, like roller coaster, you're rising, you're falling. That's a turning point. Or you're falling, then you're rising. That's what a turning point means. Turning point means from increasing to decreasing. How about that? No, so that's got no turning points. The y equals x cubed plane with nothing behind it has no turning points. So remember, the rule is at most. So third degree has at most 2 turning points, maybe less. Sometimes none. Right? So all we know is this thing is x to the third or higher because there's 2 turning points. It couldn't be x squared. But it might be x to the 7th. Who knows? Right? All right. So that's all they want on that. So we got to start with the zeros, right? Okay. So this one's at 0, 1, and 2. So we know we have an x minus 0, which is just x minus 1, and x minus 2. You with me? Those all have to be there because it's hitting 0. So this is just x, really, at those spots, right? Got to be. That's got to be part of the equation, or the graph would not be hitting 0 at 0, 1, and 2. Right? That makes sense? You plug in 0 times anything is going to be 0. Plug in 1, it's going to be 0 times anything 0. Plug in 2, the whole thing's 0. So the function has to have that at the least. It's something like that. Now, it might have more stuff.
C and E, for sure.
Might have more stuff, but it's got that at the least, doesn't it? So now, yeah, so now let's start looking. Could it be A? Let's just take it. Could it be A?
Yeah.
No, because it's
No.
the power.
It's a po- it's
Look at that negative in the front, guys. How about that?
graph.
Well, what is the in behavior of this graph? Where's this graph going eventually? Up, up, and away, right? It's going up here. Right? It's going up. So it can't be negative in the front. You with me? It's got to be positive in the front. So it's not A. Could it be B?
No, yes. Because x squared
Why can it not be B?
doesn't bounce at 0.
It doesn't bounce. That would bounce at 0 and at 1. See how the x minus 0, the x, is squared, and the x minus 1 is also squared, even power bounce. It's not bouncing at 1. Oh, it is bouncing at 1. Ooh, yeah, I better look. I didn't notice that. It's bouncing at 1 and 2, but not at 0. So it's not B still. But I better take another look. It's bouncing at 1 and 2. So second power or fourth power, some kind of even power, must be on the x minus 1, the x minus 2. I didn't notice that. Because it's bouncing at those spots, huh? So even power. But it's not B, because B also has an even power on the 0. It doesn't bounce here. It passes through on that one. So it's not B. C? Oh, yeah, it's not bouncing at 1 and 2. It's supposed to bounce at 1 and 2. It's not C. So it's not that one, not that one, not that one. How about D? Could it be D? Yeah, that looks like ours, doesn't it? Yeah, it's definitely D, huh? Why can it not, just to be sure, why can it not be E?
Because there's a 3.
No, even that.
No bouncing, huh? E's got no bouncing at 1 and 2. What about F? No bouncing. Yeah, it's D. It's D. Yeah, negative's got other problems too. It's D. Make sense on that? That good? All right, I'm going to... All right, so on this one, yeah, so this is the first really hard question. So let me just write out what we've gone through so far. So we have x squared times x minus 9. The zeros are 0 and positive 9. Zeros are 0 and positive 9. That's because those are the things that make it 0. And the multiplicity of this one is 2, of this one is 1. Because it's x minus 9 to the first power, and it's x to the second power there. So that's, the multiplicity is the power, just reviewing this again real quick. And then that means that this one is a bounce because it's even power. And this one is a pass-through. Yeah, so now to find the turning points, you have to find the max and the min on your graphing calculator. So this is our graph. So you got to type this function into your graphing calculator, put y1 in, and you got to find this. Well, I'm going to draw it over here because it's getting off the screen. You got to find this max. Somebody got that max right there, and then we got to find the min.
That's the origin.
Oh, that's the origin. Yeah, that's 0, 0. I should have known that. All right, and then what's this one then? What's this minimum down here?
6, negative 108.
Negative
108.
108? 108, well, big. Yeah, now if you graphed it, guys, and it was off your screen, remember what I showed you to do for that one YouTube I sent you? Hit table, right? So if you just type this in, oh, no, you didn't have any problem. They told you, huh? All right, good. But if you ever graph and you get nothing in your screen, hit table. And it'll show you the y values, and then you go, oh, all right, I need that kind of window that'll cover those y values. And you go back and change your y window and hit graph again. But they gave me the window, so over 6 down 108. All right, so they're saying the turning points are, notice they want ordered pair. So they want 0, 0, and 6, negative 108, separated by comma. So 0, 0, with parentheses, comma, 6, negative 108, with parentheses around it. That's what they want for that one. All right, so is everybody okay with that? So the thing, again, it went, what did it do? It went up. I forget, did it go like this? No. Yeah, it's supposed to hit the origin and be, I'm confused. It's supposed to climb, supposed to increase. So the graph was increasing. What is it doing?
Increasing from negative infinity to 0.
Oh, right, and it maxed right there, then came down, and then went back up. And this point here is over 6 down 108. Is that on the screen still? Barely. And this is 0, 0. Yeah, so we, again, so the increasing zone, so this was increasing, this is increasing, and this is increasing, huh? So it was from negative infinity to 0, and from 6 to infinity was the increasing zone, and the decreasing was in the middle from 0 to 6. We good? You guys are like, we got it. It's easy. All right. If I can. All right. So here we have a function. All right. So determine the end behavior. All right. First off, that's easy. What's the end behavior of this thing going to be? Yeah, it's just that, right? They've got it. So this one is not in factored form. That's why I wanted to, this is different, right? They've already multiplied it out, which actually is worse. We prefer factored form. This is, we're going to have to factor it ourselves. That's why I wanted to definitely show you this one. I know factoring is a problem. Especially hard ones like this. It's a hard factoring one. So I want to go through this one with you. But everybody see the difference, right? The other ones, they had the parentheses already laid out. They had factored. This one, it's all multiplied out. So it makes some of the questions easy, like what's the end behavior? Well, yeah, there you go. It's just that front term. So it's going up to the right, isn't it? Positive 2x to the fourth or whatever that is. I can't see it now. Yeah, 2x to the fourth. Okay, anyway, let's factor. I know eventually they're going to ask you to factor. We have to factor it. Can you factor? Do you remember how to factor something with 4 terms? Yeah, 2 and 2, grouping. First 2, last 2. So what do these first 2 have in common? What can you take at just the first 2? Forget about the back 2. Just the first 2, 2x to the fourth plus 14x cubed. What do they have? What's the most they have in common? What goes into 2 and 14? 2, and then x to the third, right? So take 2x to the third out of those first 2. What does that leave behind? Like times what will go back? X plus 7. Perfect. So far so good? Right? Okay, now what about the back 2? I don't know. You guys have a calculator?
Negative 18x.
Does 18 go into 126? Oh, of course it did, yeah. Yeah, there's a trick. You guys want a trick? You guys know the trick for 3 or 9? You can add the digits up. So if you look at 126 and you add the digits, it's a trick that works for 3 or 9 only. 1 plus 2 is 3 plus 6 is 9. If you add the digits and the number is something that 3 or 9 goes into, then it goes into the entire number as well. Do you guys track with that? If you add up the digits, it's a quick test. So I just looked at 120. Why I just said, of course it does, because I looked at 126, and I said, oh, that adds up to 9. So I know 9 goes in, and I know 2 goes in because it's even. So if 9 and 2 go in, I know 18 goes in, right? So yeah, 18 goes in. So divide 126 by 18. I don't know what it is, though. You guys, 7. Okay. So if I take out the minus 18x, everybody see why I took an x out? Right? Because they both, you take the lower power. One has x squared, one has plain x. So take the lower with plain x, and the minus 18. And I'm hoping it's x plus 7. Is that what you guys said? Yep. Yeah, because I want that beautiful match. You see that? That's what I was hoping for. That's what we want. So those match. So what? Well, that means this and this now both have a parenthesis x plus 7. Remove it, remove it. What does that leave behind? Actually, they have more than that. They also have a 2 and an x. Yeah, let me redo that. Are you guys looking at this right? Let me help you. I know a lot of people look at that and they get confused. Let me help you with this. What if somebody gave me 2x cubed w minus 18x w? I'm going to erase that in a minute, but let me get you the idea about what I'm about to do. You would look at that and go, they both got a w, right? And they have a 2 and an x. Huh? So you would go 2xw, wouldn't you? Right? And what would that leave? I think, what, x squared and minus 9? And then you'd factor the x squared minus 9. But anyway, right? Isn't that what you would do? Right? So this is like my w. It's just, a lot of people get thrown off because it's got its own set of parentheses. They get kind of confused. But don't let that bug you. It's just like a w. It's the same thing, same thing. It's common. Pull it out. Right? So that's what I'm going to do. So instead of w, well, I'm going to pull out, parentheses x plus 7. So let's do that. So take out 2x parenthesis x plus 7. And what does that leave behind? X squared. Erase these w's. Oops. X squared and is it 9? Right? Because all of this would go boom, boom, and would go back, right? Right? If the whole 2x plus 7 multiplied x squared, it would be 2x cubed, x plus 7. And if the whole 2x plus 7 multiplied 9, it would be 18x, x plus 7. Right? Everybody see that step? It's just like a w in common, but it's a parenthesis x plus 7 in common. I took to the front. All right, now, this goes further, huh? That's x plus 3, x minus 3. Everybody getting the hang of that? What if that was x squared plus 9? I would stop. Remember, you're getting that down. You want to have that for calculus, as I'm always saying. Right? If it was plus, I couldn't do it. It's not x plus 3, x plus 3. Right? If you FOIL out x plus 3, you get a middle term. You get a 6x. This doesn't have a 6x. That's not right. But the minus you can do, right? The minus double, I call it a double, like In-N-Out Burger. I had In-N-Out Burger last night. It's like a double, right? It's because it's XX, 3. That's what it is. A double, it's formally called a difference of squares, right? So a difference of squares, different subtraction of squares, but not the sum of squares can't be done. So, yeah, so we can do that. So let's do that. So 2x, x plus 7. So it's x plus 3, x minus 3. So there's the factoring of that whole thing. Is that good? So we'll use that for all the questions that'll help us with the zeros and with the multiplicity. Pretty much all other 22 parts. Can I just wash my hands and say that's the other 22 parts? It's all good. Maybe not. We'll go look real quick. But that's probably the main battle right there. So let's look at that for a second. What are the zeros? Yeah, you just do opposite. 0, first off. -7, -3, +3. Right? And let me go to a new screen and do that. So 2x, x plus 7. Okay. So it's 2x, x, I already forgot. What is it? 2x, x plus 7, and then, okay. X plus 7, x plus 3, x minus 3. Okay, so we got it all factored. All right, so the zeros are, this one is just 0. Right, that's just x equals 0 makes that part 0. And -7, -3, and +3. And the multiplicity is 1. Everybody just has a first power, huh? So they're all going to pass through, because they're all odd multiplicity, odd power. Right? They're all just first power, aren't they? So they're all going to pass through. Nobody's going to bounce. Right? So when we make the graph, It's going to pass through at 0, -7, -3, and +3. Is that good? So we can go to the basic graph. And the end behavior's up, so let's do that. So again, so we have 2x, x plus 7, x plus 3, x minus 3. And so the graph is going to go, what was it? So -7, 0, -3, and +3. And it's going up to the right, because the end behavior is positive, 2x to the 4th. So up to the right, pass through, pass through, pass through, pass through. Generally, that's what the graph looks like. No bouncers, all passing through. Right, and notice there's 3 turning points. It's x to the 4th, 3 turning points at most. It has 3 turning points. All right, let's see if we can. And now I'm sure they're gonna ask you to find this and find that on your graphing calculator. Find those mins and maxes on your graphing calculator, because that's where it goes from decreasing to increasing, doesn't it? Right, everybody see that? So I don't want to go through all those questions. It's going to be just like it was before. The roller coaster is decreasing, decreasing, increasing, increasing, decreasing, decreasing, increasing. Right? So when they ask you where's it increasing or where's it decreasing, you got to find those mins and maxes. Because at the bottom, the roller coaster starts going back up, or at the top, the roller coaster starts going back down. It switches, right? All right. Fools people. So let's see if you're above being fooled at this point. So, yeah, we have y equals x squared, x minus 4, x squared plus 2. Yeah, do you guys know, set that, so you know what's going to happen. You're going to get x is 0, x is 4. Those are obvious. But what about x squared plus 2? What's he going to do? So you're going to have, what zeros is he going to have?
None.
Yeah, none. So everybody see that? If you take x squared plus 2 and you set him to 0, you move the 2 over, -2, root, imaginary, huh? So no real roots coming out of that part. These are the only real roots, and the rest of the thing is normal. Okay, so that was good. I think we covered it. All right, guys, so this section, both parts, there's 2 parts, right? 4.1 part 1 and 4.1 part 2. Both are due tomorrow at class time. Have a good afternoon.